Okay, this video we're talking about a dilation, but when we're reducing a picture rather than in the last video where we enlarged a picture. So with the reduction, our scale factor, or K, is going to be less than 1. So K will be less than 1. Okay? So in this first problem, we're given a scale factor is equal to 1/3. Now I know we're scared of fractions, but really what's happening here is I'm just multiplying or dividing by 3. So I'm multiplying by 1/3 or dividing by 3. That's what happens when I have a 1/3. So you can plug that in your calculator or whatever, but if we take a look at this, if I divide my pre-image by 3, like it says to here, then -3 divided by 3 results in -1, and 3 divided by 3 results in 1. So the first thing we have to do to get the rest of these is figure out where B is located. So B is at 1, 2, -3, 1, 2, 3, -3. So then my B prime is going to be -3 and -3 both divided by 3. So B prime will be that divided by 3, and so I result at -1, -1. And we can graph this. So we have -1, 1, which is A prime, and we have -1, -1, which is B prime. If we find C's coordinates, we see C is at 1, 2, 3, 1, 2, 3. So C is at 3, -3. Once again, to get C prime, we're going to divide both of those by 3. And when I divide them both by 3, I get 1, -1, which we can graph right here. And we get C prime. Notice that my new image with my primes, which represents the image, is smaller than the original image, which is the black triangle here. Okay? That means we did it right. Over here, we have the pre-image and the image as well. And so, once again, we aren't given the scale factor, and we have to figure out what the scale factor could be. And so in order to do that, we're once again going to take the image, and we're going to divide by the pre-image. So here I have 0.5, which I'm going to rewrite as 1/2, comma 0. In order to get 1/2 and divide by 2, well, when I do that, because that's the point I have here, when I do that, 1/2 divided by 2 becomes 1/4. 0 divided by anything is just going to be 0 itself, so that's no good. When we come over here and we see W and W prime, if I divide both of these by 2, which I do in my calculator, I'll get 0.25 for each. Okay? So as you can see, 1/4, 0.25 are the same thing. If I take my pen here and I try and find X, let's see where X is located. X is at 1, 2, 1, 2, so X is at 2, 2, whereas X prime is located at 0.5, 0.5. Ooh, this should be negative, my fault. So let's just say -0.5. Okay, and we're dividing by a -2, so that's why it's positive. So X prime is at 0.5, 0.5. Which again, if we divide both by 2, we should get that 0.25 again. And then lastly, our Y is located at 1, 2, 1, 2, so 2, -2. And so Y prime, Y prime will be at what looks like 0.5, -0.5. which if I divide both of those by 2 and -2, I get 0.25, or that 1/4 again. So we can see that all of our factors are the same, and so our K is going to equal 0.25, or 1/4. Okay? And that's how we find the reduction. Now, the last thing we want to mention about dilations before we go is that another way we think about dilations is that they are similar figures in the sense that the figures do not change shape, but do change size. And we will see this again, the same concept, when we talk about congruent triangles later in the year. So we just want to introduce it with dilations.